the relation, and then we'll talk about the quadrants and values. So these are four things we'll cover in today's part one session today. Actually, we have subsequent parts as we move on. Now, before we jump into this, let's talk about, quickly touch base the what we learned in class 10, because that will be referred to over here, and it will be easy if we can just summarize what we learned. So basically what we learned is, we have, say for example, a triangle like this, right? Say A, B, C, and this is the angle theta. So this is our perpendicular, which is P. This is our hypotenuse, which is H, and this is our base, which is, so the angle opposite to theta is a perpendicular, angle adjacent is called base, and then the hypotenuse. So the relationship between these three sides of a triangle, right angle triangle, for a given angle theta is sine theta, cos theta, and then we have tan theta. So the sine theta is perpendicular by hypotenuse, cos theta is base by hypotenuse, and tan theta is sine theta by cos theta, which is perpendicular by base. So I'm assuming that you have already gone through this in class 10 and the corresponding proofs. And similarly, we have the other angles, other three angles, which is cosine or cosec, whatever you call, is 1 by sine theta, which is h by p, right? Then we have sec theta, which is 1 by cos theta, which is h by b. And then we have cot theta is equal to 1 by tan theta, which is b by p. So these are the 6 different angles, and these are the angles will be continued in class 11, but this formulas will be continuously referred to as we go to different sections, more advanced section of the trigonometry in class 11. And other additional things which you covered in class 10 is sine square theta plus cos square theta is equal to 1, sec square theta plus sec square theta minus tan square theta is equal to 1, and then we have cosec square theta minus cot square theta is equal to 1. So these are the other three formulas which we covered in class 10. And then finally we have sine of 90 degree minus theta is equal to cos theta, cos of 90 degree minus theta is equal to sine theta, tan of 90 degree minus theta is equal to cot theta. So this is all about we covered in class 10 and the corresponding proofs. So let's start with today's session, which is fundamentals. So we'll start with the first thing, which is called angle. Now how do you define an angle? So angle, say for example, there is a ray OA, right? And it moves in the anti-clockwise direction. This is anti-clockwise to B, right? And so this is called, O is called the vertex. O is called the vertex, and this rotation, the angle by its rotation is called the angle. So whenever it moves in positive, in anti-clockwise direction, which is anti-clock, then it is called positive angle. Okay. Whenever it moves in a reverse direction, which is clockwise direction, we call it as negative angle. Okay. So it can be like this, or it can be like this. So this is clockwise, so this is negative angle, this is positive angle. Okay. So whenever, so now we need to understand the unit of measurement of angle. So there are two ways we can measure unit of measurement. One is called degrees. So whenever an angle moves from here to here to here, so this is can be measured. So this is 30 degree. This is say 90 degree. This is 270 degree, and when it rotates completely, it is called 360 degree. Okay. So when it moves from, so when it moves by 1 degree, right, which is measured like this is 1 degree. So a degree is divided into 60 minutes. So 1 degree is equal to 60 minutes, which is also given in 60, right? And 1 minute is equal to 60 seconds. So this is one way of measuring, so of angle. The next unit of measure is called radian. So this is called radian. Now let's understand what is a radian is. So suppose there is a circle, okay, with center C, and the radius of the circle is say 1 unit. Okay. So when a 1 unit of circle, when the angle subtended at the center, suppose this is the angle subtended at the center, this is the angle, this is called, this distance is called 1 radian, this distance. Okay. So if it, again, if it is in this direction, 1 positive, if it is in this direction, this is -1. Okay. So we can easily define a relationship between an arc of length, say L, right, and of arc of length L for a given radius, say R, and angle theta. So whenever the situation is like this, if it is R, and if this is L, and if this is theta, right, then the relationship between these three is theta is equal to L by R, or correspond to L is equal to R. So now let's move on to figure out the relationship between the radian and angle. Okay, so we have so far covered what is a angle, what is a radian, how they are measured, angles in degrees, radians and arcs, radians. So the relationship between angle and radian. So whenever it rotates like this completely, it is called 360 degree. And similarly, in terms of radians, it's called 2 pi radians. So 2 pi radians is equal to 360 degree. Pi radians is equal to 180 degree. 1 radian is equal to 180 by pi, or 1 degree is equal to pi by 180. So this is a typical relationship between 2 pi radians and angles. So when we talk in terms of general angles, so typical degrees which we'll be using, like say 30, 60, 30, 45, 60, 90, 180, 360. So in radians, it's called pi by 6, pi by 2, pi by 3, sorry, pi by 4, pi by 2, this is pi, and this is pi. Okay, so just to take an example, like how this is being used. So if somebody is given that we have a degree of 40 degree 20 minutes, and we need to convert it into radian. Okay, so now 60 minutes is 1 degree, so 20 minutes is 20 by 60, which is 1 by 3 degree. So 40 degree 20 minutes is equal to 40 to 1/3 degree. Now we have seen that 1 degree is equal to pi by 180. So 40 into 1/3 degree is equal to 40 into 1/3 into pi by 180, which is nothing but 121 pi by 180 radian. So in a similar fashion, we can do pi radian to degrees. Okay, so let's move on further. Coming to the main, which is our trigonometric functions. So let's consider. So this is our y and x axis. This is y prime and x prime. Suppose there is a point P having a and b as the coordinate. So a is in x. So this distance, this is a. Sorry, this is b and this is a. This is o. This is a. This is m. Right? And this is the angle theta. Now this area we have x positive, y positive, so everything is positive, whereas this area we have x as negative, y as positive. Now First of all, let's cover this part. So here we have sine theta is equal to, and suppose this is our hypotenuse which remains say h. So sine theta is equal to, we have Pm by OP, which is equal to B by H. Cos theta is equal to, we have OM by OP, which is equal to A by H, and tan theta is equal to sin theta by cos theta, which is B by H. So this we already know. Now here we have A as positive, B, and because both are in the positive, so everything is positive here. Okay. So as we move, say this P comes to here, P prime, such that this distance is remains P, and this is also, but here it becomes minus A B. So this side is A, this side is minus A, and this distance remains because Y is positive and this is also H. And suppose it is the same angle. So in this case, what is going to happen is sine theta is, B, so B by H. Now cos theta, we have A by H, but A is negative, okay, because A has moved this side. It is minus A by H, and tan theta is equal to sin theta by cos theta. Sin is positive, cos is negative, it will become minus B by A. Minus B by A. Okay. So now with this explanation, let's try to draw a bigger picture. What does it mean? So these are the axes, y prime, x prime. Now here, this is called the first quadrant, this is called the second quadrant, this is called the third, and this is the fourth. Here we have x positive, y positive. Here we have y positive, x negative. Here we have x, y both negative. Here we have y negative, x positive. Okay. So in this case, since everything is positive, we have all signs are positive. Signs means sine, cos, tan, cosec, sec, and cot. Everything is positive. Here we just saw, just previously, we saw sine positive. So cosec will also be positive because it is 1 by sine. We saw cos as negative, so sec will also be negative. Since cos is negative, we have tan is also negative, and since tan is negative, we have cot negative. So we, in the second quadrant, sine and cosec are positive, rest all are negative. Similarly, in the third quadrant, we have both are negative. Since both are negative, so we have sine negative, so cosec negative. We have cos negative, so sec negative. But tan is sine by cos is negative by negative. Since both sine and cos negative, it becomes positive, and cot is 1 by tan is positive. So here we have tan positive and all signs are negative in third quadrant. In the fourth quadrant, we have x positive. So x is this part which is the base. So cos is positive and sec is positive. Rest all are negative in the similar fashion. So in the fourth quadrant, we have cos as negative and all signs are, cos as positive, all signs are negative. So the way we need to measure is first quadrant is called all, second quadrant is called sine, third quadrant is called tan, is called cos. So all sine, tan, cos, which means in first quadrant all signs are positive, second quadrant. In the second quadrant, we have sine as positive and rest all negative. Third quadrant, tan is positive, rest is negative, and fourth quadrant, cos is positive, and rest is so all sine, tan, cos. So that's how it is being measured, and that's how it is being referred to when we use this in the subsequent chapters and also in the subsequent sections. So how it is being used? So the way it is being used, I will just give you a simple example. So for example, suppose somebody has given you like this. Somebody says we have cos x is equal to minus 3 by 5 and x is in third quadrant. Okay, x is in third quadrant. So in this case, says is third means here. This is the third quadrant. So in the third quadrant, what we learned, all sine tan. So tan is positive and rest all is negative. So cos x is equal to this. So sec is equal to 1 by cos. 1 by cos is minus 5 by 3. Sine square x is equal to 1 minus cos square x is equal to 1 minus 9 by 15, which is equal to uh, 125, sorry, 16 by 25. So sine x is equal to plus or minus 4 by 5. But since it is in the third quadrant, so x is negative, sine x is negative, so sine x is minus 4 by 5. So cosec is minus 5 by 4. And similarly, we can figure out tan is also negative, sine by cos minus 4 5 by 3, and cot 1 by 10 minus 3 by 4. So this is how it is being used in all the uh, trigonometric functions. So this is what I wanted to cover today in the first part of this trigonometric functions fundamental for class 11. So we will have another part. We'll be discussing further how this is being used, what are the other uh, functions like sine 9 sine 90 plus theta, cos 90 plus theta, and the proof of that, and sine of a plus b, cos of a plus b. So all these additional things we'll be discussing in the second part, and the proof and how it is being utilized. So so in case you would like to have more sessions uh, to be conducted like this, I do conduct online tutorial session from class 9 to 12. In case you are interested, feel free to reach out to this email ID as mentioned below over here. But do provide your comments on this video. I would appreciate that. And in case there are areas of improvement, we will implement in the subsequent video sessions. Thanks for watching. Have a great day.